this lecture we will talk about k-mean clustering. Before that I will explain what are the classifications of this clustering method. There are two types of classification that I will explain in this class. In one classification is a k-mean clustering, that I will solve one problem numerically with the help of some example. After solving that problem numerically, I will go to Python. There I will explain how to use Python for doing this k-mean clustering. So, the agenda for this lecture is classification of clustering methods, under which the partitioning method k-mean clustering, that we will see in this class. So, this picture shows the classification of clustering methods. So, the clustering methods generally classified into two categories. One is partitioning method, another one is hierarchical method. In partitioning, there is another two classification. One is k-means, another one is k-medians. In hierarchical, there are two methods. One is agglomerative method, another method is divisive method, that we will explain when I am explaining this hierarchical method. So, in this lecture we are going to discuss about k-means clustering. So, which clustering algorithm to choose? Because previously I was saying two methods, one is see the partitioning, another one is hierarchical. The k-means algorithm is generally used in advance if you know how many clustering is required. That time you can go for this partitioning method. If you do not have idea how much cluster you need to do, then you can go for hierarchical. So, the another point, the choice of clustering algorithm depends upon type of data available and particular purpose. Particular purpose in the sense whether you want to have in advance how many cluster is required, or let us go for all type of classifications, later we will give it to user to choose the right number of clusterings. It is permissible to try several algorithms on the same data, because cluster analysis is mostly used as a descriptive or exploratory tool. First we will talk about partitioning method. In partitioning method, what are the data which are given is a data set of n objects and k, this is user defined, k the number of clusters. In advance we are going to know how many cluster we are going to have. A partitioning algorithm organizes the objects into k partitions, where k is less than or equal to n, where each partition represents a cluster. The clusters are formed to optimize an objective partitioning criterion. I will explain what is a partition criterion in the next slide. The objective partitioning criterion, such as dissimilarity function based on distance. So, what has happened within the cluster, the dissimilarity should be very less, between the cluster the dissimilarity should be more. Therefore, the objects within the cluster are similar, whereas the objects of different clusters are dissimilar in terms of data set attributes. So, partitioning methods are applied if one wants to classify the objects into k clusters, where k is fixed. It is a centroid based technique, because the centroid is nothing but your mean, here kind of center of gravity. The k-means algorithm takes the input parameter k and partition a set of n objects into k cluster, because as I told you, here the k is one of input parameter, so that the resulting intra-cluster similarity is high, but inter-cluster similarity is. So, what is happening? Suppose there is a cluster 1 and cluster 2. So, within that clusters there is a highly homogeneous, that means that the inter-cluster similarity is very low, but between this cluster there should be a low similarity, that means the dissimilarity is high. So, cluster similarity is measured in regard of mean value of the objects in the cluster, which can be viewed as the cluster's centroid or center of gravity, as I told you. So, working principle of k-means algorithm is, this is a flow chart. Start, in advance we should know number of clusters, then you form the centroids, randomly you can choose certain point, then you form the centroids, then the distance objects to the centroids. You find out, suppose there is an object, how far away that object is from the centroid. Then grouping based on the minimum distance. If there are 2 points, we have to take the points which is closer to that centroid into that cluster. Like that you have to continue for all points. If no object move the group, then you can stop it, otherwise you can continue this cycle. Working principle of k-means algorithm. First, it randomly selects k set of objects, each of which initially represents a cluster, a mean or center. For each of the remaining objects, an object is assigned to the cluster to which it is the most similar based on the distance between the objects and the cluster mean. It then computes the new mean of the each cluster. Here what I mean is the centroid. This process iterates until the criterion function converges. Let us see what is this criterion function. For example, E is sigma I equal to 1 equal to k, that will all number of clusters, P for all clusters. So, the P minus M modulus squared values. Here what is the P is the point in space representing the given object, M is the mean of the cluster. It is nothing but kind of your mean absolute deviation, but we are squaring that absolute deviation. Then we are summing for all clusters. For each object in each cluster, the distance from the object to its cluster center is squared and the distance are summed. This criterion tries to make the resulting k clusters as compact as separate as possible. For example, this is k equal to 3, suppose there are n type of data set, randomly I am making 3 clustering. After finding 3 clustering, then I am finding centroid of each clusters, then from each centroid I am looking at all other objects and their distance. Then I am if any point is closer to that centroid, I am bringing that point into that cluster. Then I am updating this cluster and so on. I am continuing until all the objects are grouped into 3 clusters and the intra distance is less and inter distance is more. This I will explain with the help of a numerical example. Algorithm k-means, the k-means algorithm for partitioning, where each cluster center is represented by the mean value of the object in the cluster. What are the input for the k-means algorithm? The number of clusters and data set containing n objects. What is going to be output? A set of k clusters. The k-means clustering methods, as this also I have explained in my that flow chart. Arbitrarily choose k objects from D, from the data set as the initial cluster centers. Repeat for all the points. Assign each object to the cluster to which the object is most similar, the distance is very small, based on the mean value of the object in the cluster. Update the cluster means, that is calculate the mean value of the objects for each cluster until no change. I have taken a numerical example. There are 7 individuals, 1, 2, 3, 4, 5, 6, 7. There are 2 variables, variable 1 and variable 2. As I told you, there is a small difference between clustering and factor analysis. In factor analysis, we will group the variable into different category. But in the cluster analysis, the respondents, the individuals have to be grouped. That is the difference. Now there are 7 people is there. We are going to cluster these 7 people into some numbers. Let us see what is that number. Suppose here the k equal to 2. Initially here they assume that the k is given, k equal to 2. I want to make 2 clustering. Suppose randomly I have chosen in x axis the variable 1, in y axis variable 2. So the point 1 and 3 are randomly taken. Yes, it is mentioned variable 2 and variable 1. The point 1 and 3 are taken randomly. So there are k equal to 2 cluster. So the point 1 and 3, so the position of point 1 is 1, 1. The position of point 3 is 3, 4. So what is the initialization? Randomly we choose following 2 centroids where k equal to 2 for 2 clusters. In this case, these 2 centroids are that point itself, K1 1 comma 1, K2 3 comma 4. So, calculate the Euclidean distance using this given equations between all the points and between the cluster. So, the formula for finding the Euclidean distance is root of x2 minus x1 whole square plus y2 minus y1 whole square. Since there are 2 points there are 2 things we are going to do that. The distance between K1 and K1, from that point itself, what was the distance from that same point? So, the distance is 0, and between the 2 clusters, that is 1 and 3, that is K1 and K2, the position of K1 is 1 comma 1, the position of K2 is 3 comma 4, the distance is 3 minus 1 whole square plus 4 minus 1 whole square, that is 3.61. Then the distance of K2 from K2 itself, obviously that will be 0. So, what I have taken cluster K1 and K2, the distance between 2 clusters. So, the distance between K1 and K2 is 3.61, the same value is this one. Okay. Now, we will update this. So, there are 2 points, this is cluster 1 and cluster 2. Now, what we are going to do, we will take next variable 1 point, that is the individual 2, 1.5 and 2. So, from cluster 1 I am going to find out how much far away this point 2. Similarly, from cluster 2, that is individual 3, what was the distance of 2. So, the distance from cluster 1, it is see 1.5 minus 1 whole square plus 2 minus 1 whole square. So, the distance from cluster 2, because 1 and 3 is the initial cluster, as you have to remember this was our initial clusters. So, that is 1.5 minus 3 whole square plus 2 minus 4 whole square. So, the Euclidean distance, the data set is 1.5 comma 2, the distance between cluster 1 and this data set is 1.12, the distance between cluster 2 and the data set is 2.5. So, this point is closer to cluster 1 because it is the distance is less 1.1. So, what we are going to do, we are going to assign this point, that is individual 2 into the cluster 1, that is why it is a K1. So, this point is assigned to K1. So, what happened, this point is 1.5 comma 2. So, now in this cluster 2 and 1 are assigned into same cluster. After assigning, we are going to update the centroid of this cluster, that is point 1 and 2. Now, we will update the centroid of that cluster K1, because why we are updating that K1 initially one individual, now one more individual has entered into that cluster K1. So, we are updating for that attributes. So, the centroid of K1 is for variable 1, it is 1 plus 1.5 divided by 2, it is 1.25. Then for variable 2, the centroid is in K1. For variable 2, the centroid is 1 plus 2 divided by 2, 1.5. The K2 remain as it is. Now, we will look at individual 4 whose attributes are 5 comma 7. From cluster 1, let us find out how much distance it is. Similarly, from cluster 3, we will find out how much distance it is. But in cluster 1 already there are 2 points has come. So, that our centroid has been already updated. So, the distance from cluster 1 is 5 comma, see that this 1.25 you got from this value, it is a centroid. So, this value is centroid value for variable 1, 5 minus 1.25 whole square. Similarly, 7 minus, this was the new centroid of cluster 1, you see that this 1.5. So, that square is 6.66. From cluster 2, the distance is 5 minus 3 whole square plus 7 minus 4 whole square, that distance is 3.61. So, this value we brought in the table format. So, the data set is 5 comma 7. From cluster 1, the distance is 6.66. From cluster 2, the distance is 3.61. So, this point is very close to cluster 2. So, we are going to assign this point to the cluster 2. So, 5 comma 7. Now, what happened? This point is very close to this one. So, we have assigned this into this cluster. So, after assigning, as I told you, we have to update the centroid of cluster 2 now, because cluster 2 initially we had only one point, now one more point is entered. So, the new centroid is 3 plus 5 divided by 2, that is 4 for variable 1. For variable 2, the centroid is 4 plus 7 divided by 2, 5.5. Now, this is the 4 and 5.5 is the new centroid for K2. Now, we will take another variable 5, that is 3.5. We will find out how far away this point or this individual from cluster 1 and cluster 2. First, we will find out from cluster 1. For cluster 1, it is a 3.5 minus the centroid of cluster 1 whole square plus 5 minus centroid of, that is 1.5 whole square, that is a 4.16. Now, this point 3.5 minus 4 is centroid of our cluster 2, see this one, 3.5 minus 4 whole square plus 5 minus 5.5, this 5.5 we got from this updated centroid of cluster 2. So, 0.71. So, let us bring this value into the table format. So, the distance between this point and the cluster 1 is 4.16, and the distance between 3.5 comma 5, this point to cluster 2 is 0.71. So, this point is, this data set is closer to the cluster 2. So, we will assign this point also to cluster 2. So, after assigning, what has happened? So, this point is assigned to cluster 2. Now, we will go to the next variable. After assigning, before going to the next variable, we will update the centroid of cluster 2, because in cluster 2, now there are 3 points is there, that is 3 comma 4, 5 comma 7, 3.5 comma 5. First, we will variable 1 we will find out centroid, nothing but the average 3.83. For in K2, the centroid of variable 2 is 5.33. Now, this is the new centroid for our K2. Now, you will take new individual and whose data point is 4.5 and 5. Now, let us see how much distance or how much away from cluster 1 and cluster 2. From cluster 1, see 4.5 minus centroid of cluster 1 is 1.25 whole square plus 5 minus 1.5 whole square, 4.78, that is a 4.78. Now, from cluster 2, let us see how much distance, 4.5 minus 3.83. How we got 3.83? Because we have updated the centroid of cluster 2. So, 3.83 whole square plus 5 minus 5.33. How we got 5.33? This value, 5.33 whole square. So, the distance is this one. By looking at the table, this data set is closer to the cluster 2. So, we will assign this data set also to K2. So, after assigning, what is happening? So, this point is assigned into the cluster 2. Again, we will update. Now, in the cluster 2, there are 4 data set. So, that is 3 comma 4, 5 comma 7, 3.5 comma 5, 4.5 comma 5. Now, we will find the centroid. There are 4 data set added divided by 4, that is a 4. Here 4.0 plus 7.0 plus 5.0 plus 5.0 divided by 4, that is 5.25. This is our centroid of K2, updated centroid. Now, we will take the last point, that is the 3.5 and the 4.5. Let us see how much distance this point is from cluster 1 cluster 2. From cluster 1, 3.5 minus 1.25 whole square plus 4.5 minus 1.5 whole square, that is 3.75. From cluster 2, how we got this 4 from this value, 3.5 minus 4 whole square plus 4.5 minus 5.25. So, this value is minus 5.25 whole square is 0.86. So, that value is 0.56. Again, so this point is closer to the cluster 2. So, we will assign this point into cluster 2. So, now we have assigned. So, this is one cluster. What are the points in this cluster? This is 3, 5, 7, 6, 4. In another cluster, it is 1 and 2. After that, again we will find out centroid of that cluster 2. So, 1, 2, 3, 4, 5 data set. So, add all the values divided by 5, it is 3.9. Again you add all the values divided by 5, it is a 5.51. Now, there are 2 clusters. the centroid of cluster 1 is 1.25 comma 1.5, the centroid of cluster 2 is 3.9 and 5.1. 5.1, this value will verify when I am showing Python demo. Now this is the summary of our result. What has happened? So this individual is one group, cluster 1. These people in cluster 2. So what is the property is, the people in this cluster are more similar, people in this cluster also more similar, but between these two clusters the distance is far away. Now I have solved this problem with manually. Now we will go to Python environment. So the same problem I will explain. So I have brought the screenshot of our, for the k-means clustering, we imported this required library, import pandas as pd, import numpy as np, import matplotlib.pyplot as plt. So data is this one. So this was our data. First we have plotted the scatter plot with a label. Now this was the final result of cluster analysis. What happened? See, this is one group, this is another group. This blue represents the centroid of this cluster 1, this red represents centroid of cluster 2. Now we will go to Python environment. I will tell you how to do this k-means clustering in Python. Now I am going to explain how to use Python for doing k-means algorithm. I have taken two examples. One example is what I have explained in my presentations. First we will import necessary libraries, pandas, numpy, matplotlib.pyplot and so on. Next we will import the data. The data, when you look at the data, there are 7 individuals there, variable 1 and variable 2. After that we will position these individuals in a 2-dimensional graph. So what is happening? Now we are able to see that all individuals, there are 7 individuals and their position. For example, the position of individual 1 is 1 comma 1, for position of individual 2 is 1.5 comma 2 and so on. For running k-means clustering algorithm, we have to import this library. From sklearn.cluster import k-means. So k-means equal to k-means n underscore clusters equal to 2. So this is k equal to 2. If you want to have 3 clusters, that is our next example, you have to substitute instead of 2 equal to 3. We will run this. After running, we will verify now the 2 cluster has been formed. Now we will verify the centroid of the 2 clusters. So the centroid of the 2 cluster is 3.9, 5.1, that was my cluster 2 centroid. For cluster 1, the centroid is 1.25 comma 1.5. Let us see the in picture form. This is the final output. This blue says this is the centroid of cluster 1. Here the red one says that this is centroid of cluster 2. So what happening? Now 2 clusters are formed. In cluster 1, individual 1 and 2 is there. In cluster 2, individual 3, 5, 7, 6, 4 is there. This was exactly the result which I have done in the presentation. I will take another example where instead of k equal to 2, we will go for 3 clusters. This is a different data set. So in that there are 8 individuals there. There are x variable and y variable. The same way we will plot into the 2-dimensional plot. This was that way. So there are 8 individual and their position. We will go for k-means algorithm. You see that k equal to 3. That means we are going to have 3 clusters. So when you run that, after running we can find out the centroid. So what I am going to do, I am going to enter B, then I am going to show what is the value of centroid of these 3 clusters. So paste it, now you run it. So now there are 3 clusters, the centroid of these clusters is 7 comma 4.3, 3.6 comma 9, 1.5 and comma 3.5. Now, I will show in the picture form the final output. Now, this shows the final output. There are 3 clusters which are in different color. So, this blue says the centroid of cluster 1, this red says the centroid of cluster 2, this green says centroid of cluster 3. In this lecture, I have explained the classification of clustering methods. We know that there are 2 types of classification, one is partitioning method, another one is hierarchical method. In the partitioning method, there are another 2 classification, one is a k-means clustering algorithm, another one is k-mediats. In hierarchical also there are 2 classification, one is agglomerative, another one is divisive method. But in this lecture I have covered only k-means algorithm. I have taken one numerical problems. With the help of that numerical problems, I have explained step by step procedure how to go for k-means algorithm. After that, I have explained the same problem in Python, how to make k-means algorithm where k equal to 2. Apart from that, I have taken one more example in Python environment, then there I have explained how to make 3 clusters by taking the value of k equal to 3. In the next lecture, I will explain the agglomerative method of clustering with the help of an example. Thank you.